Morning, Algebra 1. We are going to start today by working on Chapter 4 in our textbooks. So we're going to start with 4.1, which is talking about a system of equations, and we're going to talk about several different ways to solve them. So a system of equations, first off, is a set of two or more equations. When we're looking for a solution to a system, we're looking for an ordered pair that work for all equations. In other words, we're looking for a point on a graph where equations or graphs of equations touch. So our first method to find solutions is going to be graphing. So you really have to understand and remember how to graph equations of lines. So our first one says y equals x minus 3. Okay, so remember that anytime we have an equation in the form y equals mx plus b, okay, the very first step is to find our y-intercept or our b. So that's always our number that's by itself. So that coordinate is going to be 0, -3. And from there, we need our slope, and our slope is always the number that's with the x. So in this case, it's going to be 1/1. So to plot this line, I'm going to plot the point 0, -3, and then I'm just going to go up 1/1. Okay, for my slope. And it's a good idea when you're doing these problems to use a straight edge of some sort, just so that you can draw your line nice and neat. All right, so then let's go on ahead and graph the second equation. So our second equation, our y-intercept is 0, 3, and our slope, our number with our x, is -1/2. I'm going to go on ahead and graph that one, and I'm going to graph that one in a different color. So it's 0, 3, and from there I'm going to go down 1 and +2. Okay, so -1, +2, -1, +2. And I'm going to go on ahead and connect those points. Ooh, my pen did not work great. I'm going to connect those points, and the point where those two lines intersect is going to be my answer. So those two lines intersect right here at the point 4, 1. So my solution is 4, 1. Let's go ahead and take a look at the next ones. Okay, so number 2, so it says y equals -2x plus 4. Okay, so my y-intercept is 0, 4, and my slope is -2/1. I'm going to go on ahead and plot 0, 4, and from there I'm going to go down 2, +1, down 2, +1. And now I can go on ahead and connect those points. My second equation here, my y-intercept is -3, so that coordinate or point is going to be 0, -3. And my slope, or my number that's with my x, is 1/3. So I'm going to plot the point 0, -3. And from there, I'm going to go up 1/3, up 1/3. Connect those points. So the point on this graph where these two lines intersected, or where they touch, is right there, and it's the point 3, -2. So it's actually a coordinate, so that's why I'm writing it as a coordinate. The 3, -2. Okay, let's go on ahead and do the next problem. So the next one says I'm going to graph the line y equals 2x minus 1. So my y-intercept is 0, -1, and my slope is 2/1. I'm going to go on ahead and graph the point 0, -1, and from there I'm going to go up 2, right 1, up 2, right 1. I'm going to connect those points. My next equation is y equals negative x plus 5. So I'm going to go on ahead. I'm going to find my y-intercept, which is 0, 5. I'm going to find my slope. My number here, okay, is negative 1x. So my slope is negative 1 over 1. So I'm going to plot the point 0, 5. And from there, I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Connect these points. And the spot where these two lines touch is the point 2, 3. Let's see, I'm trying to find a good place to write this. 2, 3. Go ahead and take a look at another one here. So this one says x minus y equals 2 and 2x plus y equals 1. Now, this right here does not look like our other equations. The reason is it's not in slope-intercept form. So I need to get these into slope-intercept form before I graph them. So remember, our first step in getting an equation, a linear equation into slope-intercept form, is to add or subtract the x to both sides. Okay, so I have to move that x. So now I'm left with negative y equals negative x plus 2. And now I need to get this y to be by itself, and it has to be with a plus 1. Okay, so it has to be a positive y. I'm going to divide every single term here by negative 1. And I get y equals, this right here is 1x minus 2. So now my y-intercept is 0, negative 2, and my slope is 1. So I can plot those points. So 0, negative 2, and I'm going to go up 1 over 1, up 1 over 1. Okay, so I almost always put my slopes over 1, just so I don't forget that I need to go over 1. And I see a lot of students doing that too. So that's another reason that I kind of write it that way. So that was our top equation. Now let's deal with this second one. So 2x plus y equals 1. So I have to get the y by itself. My first step is always to move the x term to the other side. So I'm going to have y equals negative 2x plus 1. And that one is now in y equals mx plus b format. So my y-intercept is 0, 1. And my slope is the number with the x. So that's going to be negative 2 over 1. So 0, 1, and down 2 over 1, down 2 over 1. Oh, what did I do there? When I counted up 1, and then I put my dot on 0. So 0, 1, down 2 over 1, down 2 over 1. So my point here, where these two lines touch, is the point 1, negative 1. Let's do one more before we talk about some items that you need to know about this. Okay, so this next one is 2y minus x equals 4. Okay, so I've rewritten that. It is not in slope-intercept form. So the first thing I always need to do is move my x's to the other side. There should be a plus x. So that's going to be 2y equals x plus 4. Notice every time I move my x's over, I always put my x's first. That's because we're used to seeing y equals mx plus b. So we're used to seeing that x term first. So I'm just keeping it that way. Okay, so remember that this is a 1. This is going to be really important. This is where a lot of students mess up. So now I have to divide every single term by 2. So that gives me y equals, now that's 1 over 2, which is 1/2 x. Okay, a lot of students, if you don't put that 1 there, you put a 2 instead and you make a mistake. Okay, plus 4 divided by 2, which is 2. So now my y-intercept is 0, 2, and my slope is 1/2. I'm going to go on ahead and plot 0, 2, and from there I'm going to go up 1 over 2, up 1 over 2. I'm going to connect those points. And now let's go on ahead and solve this one. So my first step is always to move my x's to the other side. So I get negative y equals x plus 1. Now I need to divide every single term by negative 1 to get that y all by itself. So y equals negative x minus 1. So my y-intercept here is 0, negative 1, and my slope is negative 1 over 1. So that's 0, negative 1, and we're going to go down 1 over 1, down 1 over 1. And then these two lines intersect right here, which is at the point negative 2, 1. So we have a couple of different options here. Sometimes lines don't intersect. So remember that if we have lines that are parallel, they are never, ever, ever going to touch. So if we have lines that are parallel, which means they have the same slope, that system is called inconsistent. Right? If lines never touch, it's called inconsistent. And that means that we have no solution because there's no point on the graph where they're ever going to cross. So you can either write no solution, or this little symbol right there means no solution also. But then we have two different choices for when lines actually touch. When lines do intersect at somewhere, they're called consistent. If the lines intersect at one point, then the line is called independent, and it's just the coordinates of that one point. Okay, so that's like the lines we've been doing up here. But if the lines intersect everywhere, in other words, it's the same exact line, then the system is called consistent and it's dependent, and our solution is infinitely many solutions because it's touching in a whole bunch of places. Okay, so those are our three options right there. No solution, they touch on one point, or they touch everywhere. So let's go ahead and take a look at a couple of examples here. Try not to work ahead because I'm changing this one. I want this to be a plus 1 over there. So y equals x minus 1. It's already in slope-intercept form. So my y-intercept is 0, negative 1, and my slope is 1 over 1. So I'm going to plot the point 0, negative 1, and from there I'm going to go up 1 over 1. Okay, so now I'm going to go on ahead and do the next one. So my first step is to subtract x from both sides. So I wind up with negative y equals negative x minus 2. But I got to get this y all by itself. So I'm going to divide every single term by negative 1. And I get y equals x plus 2. So here, my y-intercept is 0, 2, and my slope is 1 over 1. Okay, so right here, without even graphing it, I can tell that the slopes are the same, which means these two lines are parallel. Okay, but now let's go ahead and graph it. So 0, 2, up 1 over 1, up 1 over 1. And that way we can see it. Okay, so these lines are parallel. Okay, my lines aren't perfect, so you know, it might look a little crooked. They're parallel. So now it says classify the system and give the solution. So there's going to be no solution to this. They will never, ever, ever touch. Or we can write our little symbol there. And then we need to classify the system. So anytime there's no solution, it is inconsistent. So that classifies the system. So those are our two answers right there. Now let's go ahead and take a look at this next one. Remember I said that we're going to change this negative 1 to a positive 1. Okay, so now let's go on ahead and graph these. So y equals 2x minus 1. It's already in slope-intercept form. So my intercept is 0, negative 1, and my slope is 2 over 1. So I'm going to plot the point 0, negative 1. From there, I'm going to go up 2 over 1, up 2 over 1. And then I'm going to go on ahead and connect these points. All right, my next one, I have to subtract my 2x's first. And I get negative y equals negative 2x plus 1. Now I'm going to divide every single term by negative 1 to get that y by itself. And I wind up with y equals 2x minus 1. Well, if you look, this equation and this equation are exactly the same. So my y-intercept is going to be negative 1, and I'm going to go up 2 over 1. So these are exactly the same line. So that means that there are infinitely many, let's see, infinitely many solutions. So that's my solution. Okay, but now I need to classify the system. Okay, since it does have at least one solution, it's consistent. And then I have to decide whether it's dependent or independent. And in this case, it is dependent. So that is my whole answer to this problem. Okay. So that is graphing. That's all we're doing today. Have a great day, and keep practicing on graphing if you're unsure. Make sure you know how to graph those lines, because we are going to be continuing to work with lines, equations of lines, for the rest of your math lives. Have a great day.